This video is to allow you to correct your homework for section 7.1.3. The problems are 733 through 738. So for 733, a homeowner must reduce the use of his home's electric. The home currently consumes 25 and 7/10 kilowatt hours of electricity per day, and the homeowner must reduce this amount by 20%. We have to find the amount of electricity that will be used after the reduction in two different ways using two different scale factors. So what they want you to understand is that if you're reducing it by 20%, it's also the same as using 80% of what you were using. So you've got two different ways you can do it. Again, one is to say, what is 20% of 25 and 7/10? Change your percent to a decimal. We know of means multiply. You can use a calculator to find that answer, 5 and 14/100. And then that's how much it's being reduced, but they want to know how much will they be using after the reduction. So if they're reducing by 5 and 14/100, you'll subtract that from the original amount that they consumed to get the amount that they now are using. Okay, so that's one way to do it. Again, if you want to think of that as a scale factor, it's the idea of 1/5 or 20% of the amount. And again, as I talked about, if you're reducing by 20%, that's also the same as using 80% of what you were using. So reducing by 20% means we're now only using 80% of the electricity that we were. So 80% again can be changed to a decimal and multiply, and what you find is that you then get the amount basically in one step instead of two. So both methods will get you the same answer. It's just a matter of what method makes more sense to you, but they want you to be familiar with both ways. Again, if they wanted the scale factor as a fraction, we could have made this 4/5, because 80%, of course, is the same as 4/5 as well. For 734, you're going to copy and simplify by combining your like terms, making zeros, and using the distributive property. So for the first one, you've got 4x plus 2x plus x, and you're going to combine those, and then -1 plus 2. Combine those, so you get 7x plus 1. For the second, you're going to combine your x terms, -8x plus 10x, and then you're going to combine your unit values, 4 plus -3, and you get 2x plus 1. For the third, the 1x squared will not combine with anything else, so that has to be left as is. The 3x will also not combine with anything else. That gets left as is. So the only two terms that are like terms are the constants, -4 and 4. Combine those, you get 0. So you just get x squared plus 3x. And then for the last one, you're going to use your distributive property. You've got two groups of 3x minus 2. Two groups of 3x would be 6x, minus two groups of 2 would be 4. So 6x minus 4. Here they want you to look at these division problems and answer the questions. So if you have 8 divided by 1/3, how many thirds is that? Well, if you have 8 rectangles and you're dividing into thirds, which is what this diagram is showing, then you're going to have, if you count them up, 24 thirds, 24 sections, or 24 thirds in 8. And then 8 divided by 1/4, there are 32 fourths in 8. For 736, they are giving you the speed limits in kilometers per hour, and we want to convert them to miles per hour. We're told that 1 kilometer is equal to 6/10 of a mile. So what you're going to want to do is to convert each of these. Now, if we know that 1 kilometer equals 6/10 of a mile, you can use the basic idea of a proportion. If 1 kilometer is equal to 6/10 of a mile, then, for example, 100 kilometers equals how many miles? So all of these could be solved using the proportion method or cross products. 100 times 0.6, and then divide by 1. You also could have set up your proportion as 1 kilometer equaling 6/10 of a mile this way, in which case kilometers would go across from kilometers, and miles is what we're trying to figure out. But as you can tell, you're going to end up still solving it the same way, 100 times 6/10 divided by 1. So how you choose to write your ratio, whether it's across from each other horizontally or vertically, will not matter. Now you need to fill in the answers for all of these. So, you're going to do the one for 100, then you're going to do it for 110, and so on. And so what you should end up getting is this. Australia has 60 miles per hour for country roads, 66 for motorways. South Africa has 60 for country roads and 72 miles per hour for motorways. Great Britain, 58 for the country roads, 67 for the motorways. Turkey, 54 for country roads, 54 for motorways. So again, in each case, you can solve it by setting up your proportion. Again, how you choose to set up that proportion is fine, as long as kilometers aligns with kilometers, miles aligns with miles, and we use this as our ratio. And then you are asked to simplify these expressions. So for A, you end up getting 24. B is 42. C is 2 and 5/7. D, -1 and 11/30. E is -2 and 81/100. And F is 3/8. And make sure you have adequate work to justify those answers. Again, you may want to pause to check. For 738, they want you to look over your math notes that are in the lesson, and they're also, of course, in your workbook, and then solve these problems. So the coach of the girls' basketball team weighed each players. These were their weights. First thing they want is a stem and leaf plot. So remember, with a stem and leaf plot, you should put some type of title. So in this case, maybe girls' basketball team or girls' basketball team weights. And then remember, your stem is going to be the values, in this case, of the first two digits. So, the 10 would represent values in the hundreds. Then the 11 would represent the values in the 110 up to 119, and so forth. So my leaf got moved over here, or my line got moved over here, I should say. So for example, the 106 is represented with a 10 in the stem and a leaf of 6. The 112, which is here, is represented with a stem of 11 and a leaf of 2. And then 115, stem of 11, leaf of 5. Remember that you should also have some type of key or legend as well, like, basically showing that a stem of 10 and a leaf of 6 is representing 106 pounds. The other thing I want to mention about that is remember that these need to be in order. And remember that you need to have all the stems represented from your lowest to your highest, even if they don't have any leaves. Then they want a histogram of their weight. Now remember, for their histogram, the idea is that we are doing intervals. So we're saying to ourselves, how many people are between 100 and 110? How many are between 110 and 120? And so on. Again, they should have a title here. They do correctly have a label on the horizontal and a label on the vertical. And the nice thing about a stem and leaf plot is it lends itself well to the histogram, because you can tell you have one person whose weight is between 100 and 110, and that's going to be this leaf right here. So that's how we know the height of the bar. We can tell from our stem and leaf plot there's two people who have a weight between 110 and 120. Now remember, if they fall exactly at a value, like 120 is represented by two people here, that's in this section. That's in the 120 to 130 section, and in the histogram, that's also in the 120 to 130 section. Then they want you to describe the shape and spread of the data. Is it symmetrical or non-symmetrical? Does it have one peak or many peaks? Is it tightly packed together or widely spread out? So first of all, what do we notice about it? Well, we notice that the data is symmetric. Now, what do we mean by symmetric? We mean that if we have a vertical line put through, both halves are fairly close to mirror images of each other. All right, not exactly, but fairly close. So that's what we mean by symmetric. The idea of single peaked is that there's only one highest peak in our histogram, and they're fairly closely packed together. Then they want to know for the next one, is there any outliers, meaning any values that are a lot larger or smaller than others? And there are no obvious ones. You can see that from our stem and leaf plot. You can see that from our histogram. If they are asking you about a measure of center, they mean what would be the better choice, to go with mean or median? Well, if you went with finding the mean, you'd be adding them up and dividing by how many there are, which is 122 pounds. Or, pardon me, 124 and 82 hundredths pounds. Median is found by putting them in order from least to greatest, which we already have here, and finding the middle value, which is 122 pounds. So what we see is the mean and median are fairly close together. So either one would be appropriate to use for describing the typical weight. The other thing we typically say is if there's no real obvious outliers, then probably mean or median would be fine for the typical weight. If there's outliers, that can really affect the average or the mean, so we would not typically want to use it as the best measure of center. And then what's a typical weight of a player on the team? Well, based on the mean or the median, either one of these would be fine for a typical weight. And then what is the data? Well, it's spread out in terms of its range from 106 to 147. So if we subtract those values, you get the range of 41. So range is the difference between the largest, which is the 147, and the smallest, 106. And when you subtract those, you get 41.